It is claimed that pyrolysis, which is a thermal chemical decomposition of organic material at elevated temperatures and in the absence of oxygen, could be the answer to unrecyclable plastics that would otherwise go to landfill. With me today, I have Robert Suchopa, who is a researcher working at Unipetrol, which is an institution involved in research in petrochemical industry and also education. Robert, welcome. Thank you for coming.
Yeah, thank you.
I want to start by reminding you that 45% of our plastic waste goes to landfill. Now, these plastics are very usable materials. They're chemicals which have a lot of energy within them. That's a big shame. You're working on the project PYREKOL, which is trying to do something with these waste compounds. Tell me a bit about that.
Yeah, that's true. As you said, 45% means in terms of Czech Republic around 200,000 tons a year of plastic material or waste plastic material still ends up in landfill. And there is another, let's say, 80,000 tons which is being incinerated. So, as you said, or as you suggested, or as a chemist's perspective, it's a huge waste of chemical energy stored within these materials, and we believe that there might be a solution how to extract those valuable molecules
via pyrolysis.
Via pyrolysis.
So you'll be going from waste plastic mixtures like this, and you'll be coming to more refined products such as these.
Yeah, that's correct.
And if I'm not mistaken, your general process is symbolized here,
right?
And to me, it looks like we've got a feed in here. You've got a hot tube,
right? And it's basically a hot tube.
So tell me a bit about how that hot tube works.
It's quite simple. It's a heated tube. You can heat it from outside, inside, whatever. Inside of the tube, you have this screw conveyor. You just feed the plastic in. You heat it up, you make sure that there is no oxygen left in the atmosphere, and you use temperatures in range of 400–500 degrees centigrade. And basically what happens is that these plastics will kind of melt down, so to speak, and create something that can be condensed into this form, into these type of oils or condensates, if you will. And we can take this oil, we can introduce them to existing refinery or petrochemical complexes and produce something which is inseparable from the virgin polymers, for instance, in this case. Yeah.
I see. So this process, if I'm looking at these different fractions here, I can see also diesel. So this process can regenerate both compounds that we can use as a fuel for, I don't know, cars, etc.
Yep. And
also highly valuable petrochemical starting materials, both for new plastics and polymers, or indeed other sources, whether it be feedstocks for other petrochemical outputs.
Yes, so, you're exactly correct. Yep.
Will this work though? I mean, this looks pretty clean stuff. I mean, can you use all that, really horrible, dirty plastic waste that's generated?
This is our ambition, actually, because there is a lot of clean material, and there are a lot of possibilities what to do with those already. And we aim to process the mixtures which are not so nice as the ones showed in here. Yeah, the challenge with these mixed fractions is that you have really unstable composition of those plastics when fed to the process. It directly affects the type of oil what is going to be produced at these type of pyrolysis units. Therefore, we need to find a way around that, how to handle the variability in the composition of these type of materials. And also, this oil, although it looks like an oil, right, contains contaminants and molecules which are not naturally occurring in the crude. And the crude oil is something that we generally process, that we build our technologies for in Litvinov, Kralupy, whatever, any random refinery or petrochemical complex. But these oils, they bring completely new contaminants to the discussion.
Okay, but are these same refineries, if we limit our discussion at the moment to the Czech Republic,
yep,
Kralupy,
yep,
Litvinov, can they deal, those same refineries, with your products?
There might, and hopefully we will find an answer to what kind of adjustment we need to make to this type of pyrolysis technology
Yep.
in order for the materials to be good enough in key qualitative parameters that will make those oils feasible to be used as feedstocks in already existing refineries. This is the goal.
In terms of we talk about recycling plastics, as I understand it, one of the big, let's say, problems is that you have to separate individual different types of polymers, your polyethylenes from your polystyrenes, for example.
Yep.
But your process, can it use a mixture? Is your project PYREKOL looking at taking different types of mixtures, where people have put into their recycling units a mixture of polystyrenes with polyethylenes, polypropylenes, and it can all go in one pot?
This is definitely the goal. This is what we aim to achieve. Pyrolysis as the technology is general enough that it can handle this type of materials in various mixtures. So whenever there is PET, polystyrene or polyethylene in the mix, we can't really affect. The pyrolysis is still going to work the same way as it always does, right? So from the pyrolysis or the technology that we chose to go with, it's not an issue. It represents the issue once we come back to the contaminants that I already mentioned. Because, for instance, PVC brings chlorine to the table. Chlorine is not naturally occurring in crude oil, but it is occurring in oil that you derive from PVC, right? So, and since chlorine as an atom can behave in a very troublesome ways and interact with the steel of the units in refinery, it can cause some really safety issues even and safety risks.
Okay, so and your project PYREKOL is looking at ways to deal with, let's say, chlorine contamination in some of these heterocycles and various molecules.
Exactly, this is our goal. Yeah.
But are you able to, if I take it a step back, can you use contaminated plastic waste? So let's say coming from hospitals.
Yes, we can. That's quite possible. It always will be a matter of what the law will enable us to claim, because it's not that easy a legal process to end life cycle of an hazardous waste, which is the waste type that you are referring to. Therefore, the question is not whether we can handle it. Yes, this type of technology can handle it. The question is if it's going to end already at the pyrolysis stage, or if it's going to end at the, let's say, refinery or petrochemical stage.
Okay. And Robert, let's talk economics.
Yep.
As a scientist, I know that to get from here to here, we have to roll back entropy and thermodynamics, and that is energy intensive. We have to input a lot of energy, and energy is money.
Yep.
Isn't this process very expensive?
Well, you're not mistaken there. We definitely need to put quite a bit of energy into that, because we have to shred it down at least so we can feed it. Then, as I said, it's a heated tube, so we need to apply some heat. Then we need to, let's say, transport the resulting product from all over the country to Litvinov, let's say. And then it only enters the stage of being processed via the route of fossil feedstock or standard fossil feedstock. So there is another step of huge energy intensity required for that. But from the energy balance speaking, we are definitely gaining something which is energy rich. It still has a little high heating value, right? Because it's a plastic material, and it's a quality of virgin polymer. Because once you...
So this process hits the same quality standards as virgin.
Yep. Yeah, exactly.
So that, for my mind, that means that you are able then to chemically recycle plastics to a virgin quality. And then so I can envisage that then I can go and, let's say, buy a bottle of water, and I can have a choice. The actual polymer, the material will be exactly the same, but there could be two prices. I pay a premium perhaps for the bottle which has gone through your recycling process. Is there such a market?
There already is such a market, and you can, while shopping for shampoos, for instance, you can even see examples already this effect happening. So you can choose basically the same product, but it comes with a premium price tag once it's put into a recycled bottle. So there already is a market here in Czech Republic speaking, not mentioning Western Europe. So yeah, it's definitely
okay, so there's a market, there's people out there willing to pay a premium to buy plastic containers or plastic whatever, which has gone through a recycling process as opposed to coming from virgin stock. I can tell you that. How else can we improve the economics? What about the price? Is there now a competition for this waste material? Because we've heard, I've spoken to people from, let's say, incineration plants. There's other industries and technologies which could be competitive to your own. What's going to happen to the price of this?
The waste plastic is a really wide array of, or wide mixture in terms of composition, right? And there are some components which are really interesting from the price perspective already. For instance, PET, which is more expensive recycled than virgin already from 2018. But there are still some fractions left or some residues which would be too expensive to separate or to sort out deeper. Therefore, it's not being currently recycled, or it's still being landfilled or incinerated. And talking about incineration, it really depends on what the design of the technology actually allows you to burn there. Because plastic, as I said, is a quite high heating value material. Therefore, not all incinerators can even work with this type of fuel, I would say. So, from the price perspective, we are not trying to create an unnecessary competition in these markets. We are trying to develop some solution for the fractions which are currently not being utilized at all.
But I gather you have big ambitions in that you want to eventually not only use the plastic waste generated within the Czech Republic, but you want to outreach into other nation states in Central European and Eastern European areas. So how's that going? What are the realities with that? Can we see a future where the Czech Republic could indeed be turning the waste from other countries into these usable products?
Thank you for that question, because the truth actually is that there are already enterprises who are trying to make pyrolysis work in this respect. In Czech Republic, in Slovakia, even Poland, Hungary. So the business already took a note that there is such a technology available, that it can transform plastics into some kind of oil, and that the oil could be utilized into producing some fuels or polymers or other substances of value. So this is already happening. The trouble is, with these enterprises, they are usually operating technologies which are producing subpar quality oils, right, which we can't really introduce into their existing refineries.
So it sounds like the key is a strong relationship between the people who are doing this chemical recycling with the refineries who are then going to be separating the mixtures into individual components, which could be used as feedstocks or polymers, fuels, or whatever it might be.
Yeah, exactly.
I see. And does that sort of relationship exist? Is that working well between the people who are doing pyrolysis with the refineries?
Well, good thing is there is only like 2 sites available in Czech Republic. Both is operated by Unipetrol, where this type of oils can be processed. And therefore, all the enterprises in Czech, or at least on the market in Czech Republic, definitely engage themselves to talking to Unipetrol. So there is already these dialogues happening, and we at UNICRE are helping those enterprises to identify what kind of quality are they producing, what should be maybe adjustments they can do to their technologies in order to improve the quality that they produce. So yeah, it's already there, it's already happening, and I hope that it will translate itself into forming some strategic partnerships.
Well, Robert, I do see though a vulnerability in this technology, and that's linked to the reason why we're now wearing these face masks. It's COVID-19 pandemic, which has driven down the price of crude oil.
Yep.
Now, if crude oil is cheap, then why would a refinery have any interest in buying this? So what's the plan to buffer this technology to hedge its bets against huge fluctuations in price of crude?
That's a very good question, Michael, actually. And truth to be told, to process this type of material in refinery will be always more expensive than to process crude-based feedstock or crude oil-based feedstocks. So from the price perspective, this is always going to be more costly. But on the other hand, these unwanted plastic fractions, they already come with a price. We as taxpayers are already paying to dispose of these type of streams. And we see already now that pyrolysis can operate in that price window, in that price range. So it makes it economically viable. Therefore, we see that we are not trying to create a process that taxpayers would have to pay a fortune to get rid of the plastics and transfer them into virgin plastics. We are already there with the economics.
So this solution can work economically viably without any extra subsidy from governments. You believe that there's in the free market, this thing can coexist, as it were, with the processing of crude.
Yeah, that's exactly correct. Yeah.
Okay. Well, it brings me down to perhaps one other point, is that, but why don't we just burn it? We can rather than go through all the complications of chlorine substitutions on the products, the complications with collaboration with refineries, whether it meets the standards or not, with price fluctuations in the crude market. Why don't we just take our waste and burn it?
That's another one of your good questions. Yeah, the answer is quite simple. When you burn it, you only take out the energy of these, and because this is hydrocarbons in the end, right? All the carbon that's hidden in these molecules will be emitted as CO2 in the end. So if your incinerator or your burner allows you to even use or burn these type of materials, then you will extract only energy and emit a large quantity of CO2, which is still waste CO2, right? Because this is waste plastic. So our ambition is to really take all those fractions that nobody is interested in working with, that end up today in landfills or incinerators, transfer them into oils which have quality which is good enough, let's say, for us, the refiner and the petrochemical complex operator, to introduce them into our technologies, and then we can utilize it into production of fuels or even virgin grade final polymers again. And if we make virgin polymers out of waste plastics, then I guess we close the loop and we can call it chemical recycling.
So that 45% of plastic waste that ends up just buried in the ground, it seems there's huge potential either to retrieve the energy or chemically recycle this in a very circular, economical way, leading to new value in new products. So, Robert, it seems as if you're confident about the future and how we're dealing with our plastic waste. Is that fair to say?
Yeah, that's definitely fair to say, because not only pyrolysis is there to enable a chemical recycling. We chose pyrolysis because it produces liquids, and we can handle liquids. If we would be operating technologies that work with gaseous products, we would choose another technology of processing of waste plastics. Therefore, we see that for the future, there will be an array of technologies on the market deployed, which will enable chemical recycling to happen, be it the liquid route, be it the gaseous route. But yes, I'm confident in the future, because I believe that we can find a way how to still take advantage of plastic materials that they offer and not produce another waste ending up filling our landfills or as CO2 emitted from incinerators.
Robert, may I wish you and your project PYREKOL all the best. Good luck. I'll give you a bump there. And before you leave, thank you very much for coming. I have a small present for you, a t-shirt here of our Let's Talk About It series.
Okay, thank you very much.
Thank you very much. All the best.
Thank you.